This video will work another polar integration problem. So it says find the volume below 2x plus 5y plus 3z equals 15. That is a plane. And above the xy plane, so z equals 0. And then we're bounded by, we have that circle again. Remember, we can figure out what the circle is using polar. I know that x squared plus y squared is r squared. And then I know 4, and then x is r cosine theta. So we get r equals, if I divide each side by r, I get r equals 4 cosine theta. That tells me my radius, right, based on the 0. And we can see that it changes, right? It gets bigger and smaller based on which part of the circle you are on. Okay, so I know that r then, if I were to bound r is between the 0 starts in my region r, so it starts at 0, and it goes up to 4 cosine theta. And then for theta, we can see it here, okay, it's down at the bottom. It's negative pi over 2 to pi over 2. That covers the whole circle, right? The whole down. I can't, any angle I cut off there, it's going to cut off a bit of my circle. The only way I'm going to get part of the whole circle is if I start straight down. So there's my bounds. And then we're going to, we have z. I need to figure out z is in between. Let's do that. I'm going to do it up top here. So I'm going to scroll that down. And I know that z is between, okay, it says the xy plane. That's z equals 0. And then to get the other part, I'm going to solve my plane for z. So I get 3z equals 15 minus 2x minus 5y. So z equals then 5 minus, I'm going to just leave a third out. I think that's better. So 1/3 times 15 minus 2x minus 5y. Then I don't have two fractions, I only have one. So I know z is between those two things. So I'm going to grab this. This is what my z is bounded. There we go. So that's going to be top, right? Top minus bottom. So to figure out the volume then, I'm going to go ahead and set this up. Okay, I get theta equals negative pi over 2 to pi over 2. R goes from 0 to 4 cosine theta. Then I have to replace all x's, so I'm going to get 1/3 times 15 minus 2 r cosine theta, that's x, minus 5 r sine theta, that's y, times, okay, we're going to polar, so I got to introduce r dr d theta. Right? I could just integrate. I'm going to use the 1/3 out front. I'm going to go to the two-dimensional integral and then stop and use my calculator. So I got negative pi over 2 to pi over 2. And then I'm going to go ahead and integrate my r. Okay, so the third is gone out front. So I got 15r minus r squared, because I'm up by 1, divide by the new one, cosine theta, minus 5 over 2 r squared sine theta. Oops, I forgot that r. That r's got to go through. I messed that up. So we'll go back. I'm glad I caught it. This 15, think that third's out, but this r's got to go through the whole thing. So I get 15r minus 2r squared cosine theta minus 5r squared. I'm going to just put it right here to be lazy. You guys can do that same thing. Just keep it compact. Okay, I go up by 1, so I get 15 over 2r squared. Minus, I go up by 1, 2/3, and divide by the new one. So I get 2/3 r cubed cosine theta. Same rule here, 15 over 3 r cubed sine theta. And then we got to run our r's. So r0, r4 cosine theta, and then d theta. You can see that this is going to get pretty nasty pretty quick. That's why I'm going to use a calculator. So I'm going to set this up. That way I know exactly what to plug in. Okay, I got to plug all that in. It's going to get kind of nasty, so I'm going to try to be as careful as possible. I know all this is times 1/3. I'm not going to do a bracket. I'll just leave it. So 15 over 2 times, and I'm just going to plug them in. I know I'm just going to plug it in a calculator anyway, so I'm not going to risk reducing anything down. So 4 cosine theta. This one's to the third cosine. You can see where this is going to get nasty if you were to do it by hand. 5/3 times 4 cosine theta cubed sine. That one's going to be done by u sub d theta. So you can see how we would do these. These two integrals here, split by the plus and minus there, or the minus. The first one And the second one's going to require some kind of reduction formula. I gave that in the last video, so look up trig reduction formula for cosine squared. And then this one is you let u be your cosine, and that'll take care of that sine. You could do it by hand if you like. I'd like to save some videos since we've already done quite a bit by hand. So the exact answer to this, if you'd like to check, is 44 pi over 3. And then if you used a calculator, 46.077 is what we're looking for. Again, I am mainly in this section concerned with setups to get it into polar form, because outside of that, it's just a double integration problem. It's a nasty one, but it is doable. I typically will keep things pretty tame for my exams, because we don't have the time. I don't have the time to assess you on a lot of things and give you problems that are going to take you quite a bit. So most of the time for these problems, you'll set up. So a lot of these you'll set up here. Homework, you have to go all the way through, but tests and stuff, you'll just set up this. Sorry, my highlighter's being funny. But you'd stop there. You'd write that, and that would be your answer. Again, I'm mainly concerned with your setup.